welcome to our penultimate session of this first day of the WAFX Award. This session is about food, and sometimes it's food and water. We've got a water project winner that will be presented tomorrow. We've got two projects now which are all about agricultural production in very different contexts. So to start us off, please welcome the Grid Architects with their Agritecture Home and School project. Welcome.
Hello, good evening everyone. So this is about future project, and whenever we think about future, we think about floating houses and flying houses, but is it affordable to everyone? So just keeping this question in mind, we have designed this project, we have proposed this project. Padri will share something.
So this is Agritecture Home. It's a very humble approach. The word agritecture is derived from two words, agriculture and architecture. This is a futuristic home proposed for a hot and arid climate. The project talks about sustainable living, which is accessible to all, bridging socio-economic divides with green solutions. Imagine future living. This is how we might be living. Future also holds these possibilities: lack of clean air or water for sustainers, poor soil for cultivation, and scarcity of space. So what role must an architect play in ensuring the integration of social, economic, and ecological well-being in their projects? The future also belongs to rural and economically weaker communities. This is the question we chose to address through our project and came up with the concept of agritecture. This is our attempt at agritecture, combining the structure and function of a greenhouse with the functionality of a residential and a workspace module. Why choose a greenhouse? When we talk of future home, we think of a home that addresses self-sufficiency in multiple facets, such as scalable, affordable, futuristic, sustainable, adaptable. Greenhouses are found in most places around the world. Our aim is to redefine the possibilities of agritecture. A key feature of greenhouse is their ability to house hydroponic systems. The benefits are substantial: increased oxygen levels, higher production with minimal resources, and fostering self-sufficiency among users. The plan has all sufficient functions for living within the pockets created by the hydroponic zone. This unit has a solid wall of bricks or stone fitted with suction fans on one side, and the opposite side is made up of honeycomb pad and charcoal wall with an inbuilt automatic water sprinkler system. This helps to keep the temperature around 24 degrees, ideal for hydroponics, and helps humans to live comfortably. This is a prototype proposed for a future experimental home, and it is a single sample unit which is scalable, can be multiplied and duplicated. Both sides of the structure are fitted with water channels for rainwater harvesting, usable through a well and a hand pump. The honeycomb pad and charcoal wall combined with an automatic water sprinkler system, ensuring optimal conditions for hydroponic farming. Suction fans provide adequate ventilation, contributing to energy efficiency and overall comfort. The charcoal wall regulates the greenhouse's temperature, and utilizing charcoal's natural cooling properties, charcoal also acts as a natural water purifier. The pipe integrated with suction fans absorbs cool air and recirculates it, releasing it back into the interior space through the underground conduits, much like the geothermal technique. The process not only conserves energy but also optimizes indoor temperature regulation, transforming the design into a hybrid model with a dual cooling method. The project emphasizes sustainability and eco-compatibility through several strategy, materials and technologies, utilizing reclaimed wood and MS, reducing environmental footprint. Polycarbonate sheets enhance natural lighting. The design integrates functional areas, highlighting soil-free agricultural efficiency. The project utilizes hydroponics to optimize food production, conserving space and resources while enhancing ecology. These practices provide for the family's needs and support the surrounding community through energy generation and locally produced food. This is the design for the honeycomb pad and charcoal wall. The design intervention achieving significant benefits: sustainability, self-sufficiency, innovation in agriculture, health and well-being, eco-conscious elements, urban adaptability, community engagement, multifunctional design, technological integration, and economic and climatic viability. We brainstormed various aspects to integrate agricultural elements with residential and workspace environments. The core principles of ecological, economic, and social sustainability are kept in mind. With reduced carbon footprint, improved indoor air quality, anti-aging effects, and enhanced mental well-being, agritecture stands as an example of a symbiotic relationship between humanity and the environment, redefining the concept of a sustainable future home. It represents a shift in agricultural and architectural design and sustainable living. As agritecture emerges, we imagine a future where innovation and sustainability come together to create spaces that fulfill our needs and improve our lives and the world that we live in. Agritecture is a dynamic ecosystem that redefines the intersection of urban living and agrarian practices, advancing towards equitable and sustainable development. Innovative living spaces fostering ecosystem harmony, envisioning tomorrow's eco-conscious responsive habits, emphasizing urban adaptability, vertical farming, and technological integration, redefining homes for a greener tomorrow. A very humble and honest idea for future well-being of humanity. It is the conscious responsibility of mankind. Here we have used all natural materials and textures from Mother Earth. We would like to show you a quick video for the same.
So this kind of structure can be go completely off the grid. Your dependency is not there on any suppliers like water supplying or electricity. It is completely self-sufficient structure. Thank you.
And our second presentation, also about food production, comes from Fractal Views, and it's called Parasol Agri Center. Welcome.
Agricultural Center, yes. Hello, everyone. As part of Fractal Views team, I wanted to thank the festival for this opportunity to present our projects. Also, I wanted to thank my team and colleague from University of Southern California for their continuous dedication to this project in support of Allensworth community. Imagine a fully electrified farmland that not only uses zero energy from the grid, but also produces surplus energy, turning into a power plant for the rest of the community. A symbol of sustainable agriculture, an anchor point and central hub for the community to grow and thrive within. This was an experimental project, experimental sustainable project, targeted both design and operational efficiencies to achieve a net zero building. This project was not only an environmental responsible project, but also a significant economic catalyst, creating job opportunities and housing, fostering a self-sustaining economy, and mainly focusing on a community revitalization. The community that I'm talking about is located in Allensworth, California. This is all that's left. A small plot of land, farmland in southwest Central Valley, California. A few dried up fields and dozen vacant buildings. A former aspirational community started by a man named Colonel Allensworth. It was the only town in California that had been fully financed, governed, built, and populated by African Americans. Over the years, due to many historical events and certain environmental challenges, the population has declined, and the population of the community has declined. The environmental challenges such as extreme heat and lack of urban canopy, being located in a high flood risk, and air pollution. Air pollution caused by proximity to the wildfire and factories around. This is a site location with only 2 acres of buildable area. The only buildable area land, or the only program includes the program includes a teaching and innovation lab, along with temporary housing, focusing on continuous support for the community in research, development, education, and housing. The succession to the design of this project is also backed by experimental and iterative building science analysis. Is it going to play the video? Oh, yeah. And it started by some basic fundamental questions about how does the building mitigate heat exposure while enhancing energy efficiency? Questions about the kind of a passive and active strategies incorporated into the design, and the kind of a mechanical system selections, the capacity of renewable system selections, and resiliency against blackouts, water management across the site strategies. We We started our experiment by benchmarking and setting an energy use intensity target, basically running multiple design analysis and simulation models to achieve that EUI target. The green chart highlights the key design strategies for achieving the EUI and finally net zero energy. The strategies such as maximum shading and solar control, along with indoor vertical farming courtyards to bring down the cooling load, the use of high thermal mass materials such as rammed earth for the perimeter of the building, efficient mechanical system to respond to the cooling load, in this case WRF system, and renewable energy solutions such as incorporation of solar panels alongside with the biogas from the farming waste. What you can see here, basically, this is the distribution of the program within the site. And we thought about the farmland within the different layers. The closest layer of farming abilities is closest to the building, dedicated to research and research and development for the program. And then the second strategy for that you can see into the land is the use of bioswale for the water management and collection of the water. In broad perspective, the program is distributed in 2 different wings, and each wing is equipped with central courtyards, providing ability for vertical farming that creates also air filtration for the whole building and cooling effect. As food grows where water flows, the water management for the whole site was an important factor. The step farming strategy incorporated into the design, collecting water through bioswale, you can see, and you can see here also the shaded farming close to the building that is dedicated to the research and innovation lab. The core design principle for the center was through a structural rammed earth for its high thermal capacity, coupled with overall shading shelter to build the shelter to bring down the cooling load. Additionally, to create more cooling effect, the project incorporates drought-resistant vegetations for the roof, coupled with solar shading that gives a better energy control for the building. This is the use of energy management, solar panels coupled with the bioswale system, and also conserving the energy to return to the whole grid and serve the whole community. For the final note, the Parasol Agricultural Center makes a fresh start in Allensworth community, providing enough energy not only to support itself, but also serve the whole area. Here, the community gathers under a broad canopy that offers community engagement, self-sustaining economy, and resiliency. This project promotes equitable built environment in the area and beyond, embracing community values and sustainable farming future. Thank you so much.